Number one in this improper integral problem set given by a professor at Princeton University. This is hopefully good practice on a lot of comparison tests if you are studying for an exam that involves improper integrals. Okay, so this first one is integral from 0 to infinity, dx over x cubed plus 2. This is improper because one of the limits is infinite, okay? The limit of 0 doesn't matter in this case. It will be a proper integral, even with 0, okay? So this is the strategy for a lot of problems. And you'll see if you got hold of this professor's solutions, he does this a lot, but sometimes he does it incorrectly, which I'll go over in some future problems. The intuition is correct, but then he set up the comparison test totally incorrect. Okay. So as x approaches infinity, our function 1 over x cubed plus 2, it would approach 1 over x cubed. It will behave like 1 over x cubed. As x keeps getting bigger, who cares about the small plus 2? Like a million cubed, that a million cubed will dominate compared to the small addition of 2. Okay, so we can treat it like almost like 1 over x cubed. And we know that integral from 1 to infinity dx of x cubed converges. So likely this integral that we're interested in will converge as well. That's our intuition. And a lot of times, this intuition will help us set up the comparison that's needed. Okay. So we can break this integral up into integral from 0 to 1 and 1 to infinity. Okay. We want to do this because, first of all, this first integral over here is finite. We don't have to worry about that. Okay. This second integral is still improper. And now we compare this function, 1 over x cubed plus 2, for x is greater than or equal to 1, it's less than or equal to 1 over x cubed. This is the function we had the intuition about. Okay? Since it's less than or equal to 1 over x cubed, and since we know that this improper integral of 1 over x cubed dx from 1 to infinity converges, I even showed the work here for completeness. Because this converges and are things even smaller, by comparison test, our integral must converge as well. Okay? So that's it for number one. The key point I want to highlight once again is this intuition that we can have. Okay, this works really well in a lot of cases, and it helps us determine what to compare to a lot of times, as we did right here. We compared to 1 over x cubed. Okay, that's it for this video. Hopefully this was helpful if you're studying for an exam. Just having this intuition will greatly help. I highly recommend thinking about it like this. All right. Hopefully see you in the next video as well. Bye.